The problem is that there are no replacement components available in the market directly. Producers need approximately 20 to 30 years support for these systems to maintain the systems. So this is pretty dramatic.
Welcome to We Talk IoT, where we explore the ideas and impact behind AI-driven tech of the future and how data creates real business opportunities. To stay ahead of the innovation curve, subscribe to our newsletters on the Avnet Silica website. I am your host, Ruth Haydock. Today's story begins with a crisis hiding in plain sight. Across thousands of buildings worldwide, the controllers managing lifts, heating, and security systems are aging, and some replacement parts don't exist anymore. For 30 years, local operating networks have quietly powered building automation. And now the key components face end of life, leaving companies needing up to 8,000 controllers they cannot obtain. My guest today is Martin Mentzel, CEO of Safesquare, and they have developed a solution that replaces these discontinued controllers without costly system redesigns. Let's discover how legacy infrastructure meets modern innovation. Welcome to the show, Martin. I'm really happy to have you today.
Yeah, I'm also happy to be here.
Martin, for our listeners who have not heard of local area networks or LON technology, what is it and why has it been so important in building automation?
Yeah, so it's a bus technology, but it's rather non-comparable with normal bus systems like Modbus or other systems like this, because it's a multi-master system. So that means every device is part of a complete controller network. There's no central station in it, and every device is independent on the other devices. So we have no single point of failure in this network. This is one advantage. Yes, it's very performant on a two-wire system and very robust. And so it was a favorite, centuries ago and even 10 years ago, and to build systems in the building automation and in other areas. Right?
Okay. Yeah, you mentioned decades ago, and it hasn't been replaced since, as far as I understand it. What has made this technology so enduring?
Yes, it was mainly media support. So that means it has, of course, Ethernet support, but it also has a legacy media support like just two wires, power line communication, RF communication, and so forth. So the interesting thing is that the protocol in each media is the same. There is no gateway in between. It's a transparent infrastructure, can be built up using so-called routers. So it's a very good scalable system, which makes it very interesting for large systems like in building automation, but also for specific systems in other vertical markets.
Mm-hmm. So let's talk about the problem. Which specific components are now no longer available, and how serious is this shortage?
Yeah, so to understand this, we need to go a little bit into the past. So it has been brought into the market in the beginning of the 90s, last century. And this is pretty long ago, of course. And it has been developed by a company and provided by the company babi-LON. And over the last years, babi-LON was merged into, now finally, into Renesas for the components to be supplied. And Renesas now has decided to discontinue these components that are normally mandatory in device design. And the so-called components are mainly called like neuron chips or transceiver components, right? And there's a various of components that have been discontinued, not going too much into detail. But the problem is that there are no replacement components available in the market directly to be replaced, for example, one by one. So there are other solutions needed to solve the problems, to continue with production and supply for end customers, right?
quite scary, to be honest, because you mentioned this technology affects lifts, escalators, security infrastructure in buildings. And you mentioned, I think, one manufacturer of lifts who now needs 8,000 controllers.
At least per year, yes. And there are other markets even. It's also about access control in buildings. It's about door control, so driving doors and opening doors and so forth, all this area. It's also in medical systems, it's implemented in hospitals, for example, not just for normal building automations, for example, for gas management, in the operation rooms, for the personnel there, also the lights that are used during such operations. These are very, very dedicated and specific markets even. And the problem here is also a little bit more dramatic because it's not the components or the devices are not sold as we know from, for example, for laptops or mobile phones or so, which are replaced, for example, after 3 years and so forth. So it's more an industrial view on these systems and devices. The producers need approximately 20 to 30 years support for these systems to maintain the systems and so forth. So this is pretty dramatic, and therefore solutions are needed to continue for a lot of manufacturers, right?
But thank goodness I have you on the show today. So
yes, of course.
So Safesquare has built, I think you call it a new backbone IP stack. Can you explain in simple terms what this means and how it helps?
Yes, okay. Yes, so we have developed a hardware and software platform to really replace components inside of existing designs of such devices. Unfortunately, a redesign is necessary. There's no one-to-one replacement for the existing components that have been discontinued. However, all the applications that have been driven so far can really be managed by the new design. And so we are using ST microelectronic CPUs and of course also some other components around to attach to the legacy bus system, for example. But we are only using normal components, so no extraordinary components are in the design. With our solution, a producer can really produce the devices for next decades. So this is no problem.
Okay. You mentioned that there is a little bit of redesign necessary to switch from the old system to your system. Can you walk me through that? What happens when someone calls and says, help, I'm running out of these controllers.
Yes.
They are failing. What do I do now?
Yes, clear. So currently, the design consists of a component, a CPU, which is called neuron chip. It's an 8-bit technology. It has a pretty huge housing, but this is due to the history, right? And we are now using modern chips with smaller footprints, of course, but also with 32-bit technology, right? So there are impacts on the hardware, of course, because the chips need to be designed into the existing designs that are there. But it can also be an advantage because it has more GPIOs and interfaces, those new CPUs in comparison with the neuron chips. And so it can even avoid to use components that are currently in the design and also generate costs, right? On the other hand, the software needs to be redesigned. So we are using a real-time operating system with 32-bit structure, of course. And it is necessary to redevelop the software. It's also a porting issue, of course, but it cannot be ported directly because of the pretty high jump from 8-bit to 32 bits. But if somebody understands his own software, it should not be a big deal, right, to implement this to this new design.
And when I think of building automation, especially with a use case you mentioned in hospital environments like an operating room, I suppose you cannot afford any downtime in these critical infrastructure systems. How do you handle that?
The thing is that currently the neuron chip is pretty robust. It continuously works if the development is done correctly. And it has some issues when, for example, updating software. So it is possible to update the software inside of the devices over the network. So this is also not possible with any bus system, but with LON it is possible. So it is also possible with our solution, but with the neuron chip, the problem is that there is a downtime when downloading the software into the device because of the flashing process inside. And with our solution, we have no downtime during the transfer of new software, for example, into the device. And it can be done in a dedicated time to do a reboot, because a reboot is required, but this only takes a short time. The time can be managed.
Mm-hmm.
Yeah.
And what does it typically cost to redesign an entire system versus also your solution?
So the redesign is with regards to, yes, the hardware, of course. So with the hardware, it is just a general cost that everybody, I think, that is interested in the cost knows. What needs to be kept in mind is that the testing for EMC and so forth needs to be redone, because we are, of course, running the new CPU with a higher frequency. So it's really requested to do an EMC testing again with the new design. With the software implementation, this effort is, of course, due to the scale of the software, of the size of the software, of the functionality of the software, and so forth. So if it's an easy application, so pretty less to implement, then it could last maybe 2 or 3 days.
Okay.
And it should be done, yes.
Do most people know that they will have a LON problem, or do they only realize it until something breaks?
Yeah, so there was, of course, a discontinuation notice done by Renesas. And I think a lot of, people working for manufacturers of LON devices know this already.
Okay.
As we recognize currently, because we currently also get new requests on a day-by-day basis, it's under process, I would say. And the problem is that the last time buy is by September 15th. So this is from now pretty close or even gone. And then probably also people will wake up then from a scary dream and come to us maybe and ask for a solution, right? But yes, it's in process, and we are already talking with a lot of these OEMs to solve the problems, right? But it's also a road to drive, right? So most of the OEMs currently are ordering for the last time buy, or have ordered for the last time buy, to have something on stock for a definite period. This is on their purpose, of course, how long, to then jump to a new design maybe afterwards.
Sure.
Yeah.
So that you have a fail-safe, you have like the discontinued controller in stock in case you don't find a new solution, and then you have the time and the leeway to react in a timely manner and not in a panic mode, I guess.
Right.
Okay. Tell me a little bit about Safesquare's story. What's your background and what led you to tackle this problem?
We are working on with the LON technology since 95, so pretty early, a few years after the things came out to the market. From the original position, we are a service provider, development services provider especially, and we have in the past developed a lot of LON devices for different manufacturers, including all the software part, of course, on the embedded side, but there's also in a lot of cases, the need of configuration software on a PC side or something else to get this up and running in the field. And this is also part of our job to develop those things. And we had to come to the babi-LON solution. Approximately 10 years ago, we had a request from a big customer buying a lot of chips, so neuron chips, per year, and they wanted to get a replacement for this. And so this was the initial starting point to begin with the development, and we developed it. It was a little bit specific in the overall development for this OEM, but this was the starting point for babi-LON. Mm-hmm. After that, we continued to work on this platform, and we improved it and extended it by specific functionality so that it is really, on the first place, comparable with the neuron chip, with all the functionality, but in addition has also some extended functionality that the neuron chip, due to the technology that has been chosen in the past, is superseding this. Okay, so that we have even advantages not only to continue with the same functionality for OEMs with their systems, but also to, for example, add IP communication directly into the design, even over the legacy media like the two wires or the power line or the RF or what have you, right? So this is also an issue for OEMs maybe to choose for our platform, because we lead the existing architecture of their systems and design and so forth, really without big changes to IoT technology.
We will take a short break. Stay with us, and we will be hearing from our guests very shortly. This podcast is brought to you by Avnet Silica, the engineers of evolution. Subscribe to our Avnet Silica newsletter or connect with us on LinkedIn. If you want to learn more about us, we have put information and links in this episode's show notes. So what kind of started as a niche market, you could identify this as an opportunity, and then you saw that there really was a business there. Is that how it worked?
Yes, the one or the other might know, for a lot of years, approximately 15 years, LON is called a dead technology because
not so dead anymore.
Yes, and but this is not true, right? It's just been not continued by dedicated manufacturers of devices. This is true. But it's not a dead technology, because it will even continue after the discontinuation of the chips. We see this currently because it's really a good technology to be implemented as a very robust, easy to install and easy to use system. Right. So it's really has big advantages, for example, against CAN technology, Modbus RTU technology, and others of this sort based on those transceiver technologies, right? And this is really a big advantage, and even new customers could jump into this boat and can have the guarantee that this is not a single source solution, that this is really a long-term solution for their devices and systems.
Can you explain this also with use cases? Like we have already mentioned some, you said anything building automation, but I think also transportation, hospital infrastructure. What else is there to explain?
Yes, so for example, when you talk about bus systems, you first have the limit of course, number of devices to be put to one wire, and also the distances of communication. And we are talking with LON with regards to the two-wire technology, for example, about at least 400 meters to 500 meters with free topology. What does it mean? That means you can wire the cable as you want. You do not need to take regard to bus structure. You can make your trees. You can even build rings with this system. Okay. So it's very easy for any technician out there to install it with the wiring, and you have a distance of approximately 500 meters in this case. If you use the same technology, for example, as a bus technology, you can reach out for 2 kilometers in the overall distance of this wiring. And this is the reason why it has been installed in a lot of buildings for the normal building automation, which means lighting, sunlight driving, HVAC control, and so forth. So because of the distance, because you have a lot of area, so for example, a few hundred square meters per level, then you can easily connect these devices with the two wires. Right. And this is also different to other systems.
Okay.
So some other use cases beyond that are, as you mentioned, the lifts or even escalators. They are connected also with the same technology. Why do manufacturers choose for this technology? So they have a cabin. Okay, everybody knows, and everybody used it already. And this is driving, right? And then they have a central station, mainly where the drives are and all the other mechanical things. And then the cabin is moving, and there is a cable necessary to the cabin. And this cable needs to be rolled up and rolled down when the cabin is moving, and this needs to be the right cabling. And during all these scenarios, the communication needs to properly work. This, for example, can be qualified by the manufacturers with dedicated cables, and they have a good experience that this works excellent. And for this reason, they would like to stay, right, with the technology. Yes. So in the hospital, we have a similar use case from the technology point of view, like in the building automation, because also there with the stations for the patients, it is also a big area to be managed, right, by the cabling. And so it's a similar approach in this case.
Okay.
Yes, for power line technology, which we also provide a solution for, this is, for example, used in trains. Probably nobody knows about that. So in trains and in other vehicles that are available by dedicated manufacturers to control, for example, the brakes, to control the doors, and such things. So it's a very good variety of applications that are covered by the technology. As I mentioned, all these applications, everybody can imagine that there are really reasons for OEMs to stay with the technology. And I would think there are also good reasons for manufacturers that are in dedicated fields of business to decide for this technology, even if they have not used it before.
Okay. That fits perfect to my next question. Looking ahead, my question was if this solution is a bridge to something new, or if you see the LON technology continuing for the next 30 years with your improvements.
I see it more continuing. Of course, in a lot of areas, the IoT approach leads to mostly Ethernet connected systems. This is also true for building automation, to take this application. So in building automation, when something is really not only modernized normally, but even recabled with this modernization, the new devices have more power consumption. This is the first thing. So it's less efficient due to power consumption for the devices themselves. And this is a big factor over the operating time, because the operating time needs to be viewed as at least 20 years.
Yeah.
And this can be avoided when using just the two wires. The only thing that is the Ethernet connectivity, or the main thing that the Ethernet connectivity is needed for, is for directly IP communication. But we extended our platform to directly communicate with IP over the two wires. So if somebody has the two wires or wants to use two wires in a new building, for example, or during modernization, it's really possible to have a control network over the two wires using the LON technology and in parallel using IP for connecting to some management systems. So in the building automation, the protocol BACnet is mainly used to connect to the management system. For this reason, we also developed in our platform a BACnet stack that is certified and that directly leads to a communication inside of the devices to directly communicate over BACnet IP. We cannot go too much into technical details to explain all the stuff because it's a little bit more than one sentence. But we have achieved a good solution to directly connect to a so-called BMS, a building management system, over BACnet IP directly from the field, from the very end, lowest end to the BMS. And so it's even better in this case than using, for example, Ethernet controllers that have subsystems. So there are a lot of Ethernet controllers, of course, in the building automation, for example, but there is a problem, for example, to connect a room panel, because if you have a socket in the wall, it's not possible to use a patch cable because it's even too huge, right? It's not manageable. Yeah. So you need the two wiring in any case, but if you use, for example, Modbus, this is just an extended I/O. It's not a direct I/O of the Ethernet controller, and so you cannot manage everything on the sensor and actuating side in this case. And with the LON directly implemented in the sensor and actuator and directly IP communication, it's really superseding the features that can be used with this technology then. Right? And so I'm pretty optimistic that this also leads over time to, in a sense, to a revival of the LON technology even in the building automation market.
Interesting. Okay. Yeah. It seems the message is clear. LON is here to stay. Yeah.
Yes. It will not go away, unfortunately. Yes.
Yeah, and I think by the time this episode airs, you might have already also done a webinar on the topic. So I will put the links in the show notes once it's out so that our listeners can do a greater deep dive into the topic and learn more about LON and the technology and the solutions you're providing.
Yeah, this is really great. Thanks.
So the LON story really highlights the challenge. I think we will probably see more often that critical infrastructure that is built to last decades suddenly faces component shortages. It has been really great to learn about your solutions and all the engineering work you have put into this. Thank you so much, Martin, for coming on the show today and sharing your expertise. This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.